Question from February March 19, 9709, variant 32. Question number is 5. The variable x and y satisfy the relation sin y equals to tan x, where y is greater than minus 1 over 2 pi and at the same time less than 1 over 2 pi. Show that dy by dx equals to 1 over cos x into square root of cos 2x. So this equation is given, and this is implicit equation. This is implicit equation, and we are looking for dy by dx. Uh, Sin y is equal to tan of x. So this is implicit equation. I'm going to differentiate it. Differentiate with respect to x. So as it is sine of y, you can differentiate sine of y. The derivative of sine of y is cos of y. Don't forget to multiply by the derivative of angle. Angle is y, and the derivative of y with respect to x we know is dy by dx is equal to tan of x differentiation with respect to x is secant square of x. We want to find this expression, and this expression is entirely in terms of x, so we want to remove this. So we're looking for the alternate expression of cos of y in terms of x. So for this, let us label this as 1. Here given that sine of y is equals to tan of x. As sine of y is given as tan of x, we also know that sine square of y plus cos square of y is equal to 1. Sine square of y is tan x, so this can be replaced by tan square of x plus cos square of y is equal to 1. So cos square of y in this way is 1 minus tan square of x. There is no tan in this required result, so let us write this tan square of x as 1 minus sine square of x over cos square of x. So you can take LCM cos square of y. LCM is cos square of x. So cos square of x minus sine square of x over cos square of x. So numerator is double angle formula. Cos square of y, cos square of y, so double angle formula. Cos square of x minus sine square of x is cos 2x over cos square of x. And cos of y, because we need cos of y. So cos of y in this way is square root over cos square of x. So usually we write plus minus, but as it is from minus pi over 2 to pi over 2 here, and cos is positive in these two quadrants, so just write the positive sign here. Only choose the positive sign. So cos of pi in this way, so this working is very, very important. Cos of 2x over cos of x. So this is number 2. So listen, we started with this given thing, and I used the basic identity sine square plus cos square equals to 1. So I replace sine of y by tan of x, and then there are simple steps of simplification, and I removed tan. I replaced tan by sine over cos, because in the required result there is no tan, so this is in terms of cos. So removing tan by writing sine over cos, and by taking LCM here we have the double angle formula. This is double angle formula. So double angle formula, cos square plus sine square minus sine square is cos 2x. Then you take square root, and we have the expression for cos of y. This can be used here, put in 1. So you put 2 in, using 2 in 1. So cos of y dy by dx, cos of y dy by dx is equal to, it was secant square of x. Secant square of x we know is 1 over cos square of x. Secant is 1 over cos square of x. Left hand side cos 2x with square root divided by cos of x dy by dx, and the final step is that you move. So we have uh, 1 over cos square there. You can you can move 1 over cos square of x, cos of x over cos 2x, leaving dy by dx on the left hand side. And the final step is remove the square, and the result is here that dy by dx is equals to 1 over cos of x into square root of cos of x into the square root of cos 2x. And yes, we wanted to get the same thing. 1 over cos x, cos 2x. As the result. Thank you.